Hi, welcome to Steve's Cycle. My name's Steve. Today we're going to get started on our Can-Am 125 engine. I've already got the engine took apart. I wish I could have made some videos on that, but like I said, I've already took it apart before I got into making videos, so this is where we're at right now. I've took everything apart and cleaned it, and I started on the crankshaft last week. I was going to take it apart and put a new crank bearing and put a new crank pin in, and check the rod journal, you know, to see if it was worn any. Well, I ordered a crank pin. I found the crank pin the right size and length, and a new crank bearing. So, and the rod, I measured it, and it marked out well within spec. It's hardly worn any at all. So I just done a light honing, you know, just to smooth it up a little. But the rod is actually in really good condition, so we're going to go back with this rod because Can-Am parts are not that easy to find. So a rod, if you could find it, no telling how expensive it would be. So I'm glad that the rod was in good shape. Well, the problem is, I went to put the crank back together, and I noticed that the rod was rubbing on the side of the crank web. You can hear the noise, and let's see if that'll focus. You can actually see where the rod has been rubbing. You see how shiny it is, and I noticed that there was no thrust washers on either side of the connecting rod, which is very unusual. You know, most all two-strokes that I've ever seen have had thrust washers on the side of the rods. So I thought, well, you know, that was unusual, and I knew this right here couldn't work because I mean, you can actually push the rod, and the rod will actually lock up on the side of the webs on the counterweights. So I found a service manual on the internet, and I bought it from a guy in Texas that deals with Can-Am parts, and I looked in the breakdown, and it does have thrust washers, where it's supposed to have thrust washers. And right here's the breakdown. Let's see if we can get that to focus, and you can see right there that there are thrust washers on both sides of the rod. And this is for the 175 qualifier and the 125 MX-6. So apparently somebody has had this crank apart years ago, and for some reason, I don't know why, they didn't put the thrust washers back in. I mean, it's very unusual, but that's what's happened. I had some thrust washers. I build a lot of crankshafts, so, you know, I try to keep, you know, some thrust washers on hand. But these that I have are 22 millimeters on the inside diameter, and my crank pin is 20 millimeters. So I mean, there's a chance that could work, but I mean, that may make some noise, and plus it will probably wear a groove in the crank pin over time with it flopping around like that. So that's not going to work. The only concern I had was the width of the crank. What the width of the crank, the final width of the crank would be once it had thrust washers in it, because this crankcase is very narrow. If you look inside there, you can see how narrow the actual crankcase is. So if you went with too thick of washers, because I don't know what the width of the original thrust washers would have been. So if you go with too wide of thrust washers, then the overall width of the crank is going to be too wide, and it's going to rub the crankcase. So today we're going to measure the crankcase, and we're going to measure all the individual parts of the crank and rod to see what the width of the washers need to be. So First I'm going to measure the inside of the crankcase. I'm going to use a snap gauge to do that. To determine what the width of the case is. I'm going to use the dial indicator here, or the micrometer, sorry. Alright, we're going to come out with 1 inch 901 thousandths. So I'm going to write that down. Okay, that'll be our case. 1 inch 901 thousandths. Now we're going to measure the width of the crank webs. Okay, we'll come up with 520 thousandths. We're going to write that down. Okay. And they should be the same, but we'll check it anyways and make sure both of them are the same width, those sides, and they are 520 thousandths. So each web is the same width right here on the bearing surface. Okay, now we're going to measure the rod, the width of the rod, to determine what it is. Okay, we'll come up with 665 thousandths. Write that down. Okay. Now, these washers that I have here measure about 40 thousandths. So we're going to add that. We're going to add 2 washers in, so that'll be 80 thousandths for the width of both washers. And we'll just see if it works out by putting 40 thousandths thick washers in. So I'll write that down. And the side clearance, in the book here, the side clearance calls anywhere from 8 to 20 thousandths. So most of the time on crankshafts I like to put them somewhere around 15 to 18 thousandths is normally what I go with. So just because the crankcase is so narrow on this engine, I'm going to put it down as 15 thousandths side clearance, and we'll add that together and see what we come up with. So we got 520 thousandths plus 520 thousandths plus 665 thousandths plus 80 thousandths plus 15 thousandths for side clearance. And that comes out to be 1 inch 800 thousandths. So our crankcase is measuring 1 inch 901 thousandths. So that's a difference of, you know, about 100 thousandths, 99 thousandths, so to say 100. So that's going to put us at about 50 thousandths for each side of the crank webs, which is not a lot, but I mean it is clearance. So, well, look through all the washers that I have, and I don't have anything that's 20 millimeters inside diameter and 40 thousandths thick. So I'm going to attempt to make some washers, some thrust washers, and I found this piece of brass that I had. So I got several pieces of this, so I'm going to try to use this to make the washers. The only thing I got to try to figure out some way of holding it in the lathe so that I can machine it. I'm going to machine the surface to start with, and then we're going to use a cutoff tool and cut it off roughly you know, a little larger than 40 thousandths, and then we're going to have to flip it over and figure out some way of holding it to do the final side, you know, to face the final size. And so it's going to be kind of difficult to hold because it's such a you know, be such a thin piece. So I'm going to have to think about it just a little while and figure out, you know, how we're going to do it, and we'll come back, we'll get started on the lathe machining this out.